Okay, so in class we did part of part A. I'm going to just recap that a little bit. So we had a standard normal distribution with a mean of 0 and a standard deviation of 1. Here in example 4 from your worksheet, we have a mean of 4 that's given in this statement right here, and a variance is 9, so that means that your standard deviation is 3. If we're going to compute the probability that x is less than 6, well then we need to standardize that so that we can use our standard normal tables. So everything, all of the variables here, the x and the 6, need to get transformed. We're going to do that by subtracting the mean, and then dividing by the standard deviation. That's up here in this box. So you can see that up here. So I've done that with the right-hand side of my inequality within the probability statement. You can see I wrote 6 minus the mu over standard deviation. So here we end up with our standardized problem, the probability of z being less than 2/3. I used my probability table to find out what that equals. So here's my probability table. And 2/3 is 0.6 repeating, so I went down this column to 0.6, and then, let me be able to write on this here. I went down to 0.6 here, and I followed that row across until I got over to 0.6, and I rounded it to 0.67, so I'm using that value of 0.7486. If I round that, I get to 3 sig figs. I'm going to get come on and cooperate with me, smartboard. I'm going to get 0.749. There you go. So now looking at part B, we have the probability that x is greater than or equal to 1. This one is a little bit more challenging, you'll notice, because the inequality is different. So if I think about what that looks like, my mean is at 4. This is from the previous problem. If I count up 1 standard deviation, I add 3, I get 7. If I count backwards 1 standard deviation, I get 1 right here. I'm interested in the probability that x is greater than 1. So that's everything up here. That is the same thing as 1 minus the probability that x is less than or equal to 1. Here you can see that I've been a little bit sloppy with my inequalities, but it's not going to actually make any difference whether it's a strict inequality or whether it equals the endpoint. Now I'm going to standardize this. So I end up with 1 minus the probability that z is less than or equal to 1 minus my mean, which was 4, come on, right, divided by 3. That's the same thing as 1 minus the probability that z is less than or equal to -1. This seems nice and easy. We go back over to our standard normal table, and unfortunately you see that I only have positive z values here. So I need to do something about that. So what I have in red now, this is for z. I'm trying to find this probability. There's -1, and I'm trying to find this probability down here. So I need to be able to flip this around somehow so that I can deal with positive values. Seems to me that if we use the symmetry of this graph, that area that I've shaded in red is equal to this area that I've shaded in blue over here. That area is the probability that z is greater than or equal to 1. Be really careful here, because this statement looks very similar to the statement we were originally trying to evaluate up here, but that original statement was with x, and now I'm working with z, so things are slightly different. And I can again flip that around so that this is the same thing as 1 minus the probability that z is less than positive 1. Now I think I'm good to go. So this ends up being 1 minus, and I'm going to come back to my probability tables, and I need to find 1. 1 is right here, 1.0 is right there. So that's 0.8413. 0.8413. I'm not going to round until the very end. So what is that? 1 minus, sorry, you know my arithmetic skills, leave something to be desired. So I'm going to use my calculator to evaluate that. 1 minus 0.8413. Whoops. 3. And I got 0.1587. So to 3 sig figs, that's going to be 0.159. So there you have it. That's how you do Part B with our standard normal tables. Awesome.